Let us start with test of significance. For small samples, n is less than 30. हिंदी में इसे सार्थकता का परीक्षण कहते हैं. In this section, we deals with students Ttest, 2-min Ttest for independent sample and pair Ttest for correlated or related samples. Parameters and statistics, प्राचाल एवं प्रतिदर्शक. The statistical constants of the population such as mean, mu, variance, sigma square, correlation coefficient rho and proportion p are called parameter. While statistical constants computed from samples corresponding to the parameters are namely mean x bar, variance capital S square or small s square, sample correlation coefficient small r, proportion p, etc. are called the statistic. Parameters are the functions of the population values, while statistic are the functions of the sample observations. Test of significance. Test of significance, it is a kind of test which enables us to decide the opinion about the population parameter on the basis of sample results, that whether the deviation between observed sample statistics and hypothetical parameter value, the deviation between two sample statistics is significant or might be attributed due to chance or fluctuations of sampling. सार्थकता परीक्षण यह एक प्रकार का परीक्षण है जो हमें किसी समष्टि के प्राचाल मान के बारे में निर्णय लेने में सहायता करता है कि प्रतिदर्श अनुमान और प्राचाल मान का विचलन या दो प्रतिदर्शों का विचलन सार्थक है अथवा मात्र प्रतिचयनों के उतार चढ़ाव से प्रभावित हो रहा है. ये हम टेस्ट ऑफ सिग्निफिकेंस के द्वारा देखेंगे. व्हाट इज नल हाइपोथेसिस? Null hypothesis is a statement about the population parameter which is tested for possible rejection under the assumption that it is true, and it is usually denoted by H0. Generally it is called no different hypothesis because we hypothesize that the statistic parameter or ratio about which the statement has been developed is not different from the population parameters. It is also called the size of critical region. शून्य परिकल्पना के प्राचाल मान के बारे में एक ऐसा कथन है या परिकल्पना है जिसका यह मानकर परीक्षण किया जाता है और कहा गया है कि यह कथन सत्य है. शून्य कर परिकल्पना को H0 से प्रदर्शित करते हैं. सामान्यतया इसे अंतर्विहीन परिकल्पना कहते हैं क्योंकि हम यह परिकल्पना करते हैं कि प्राचाल मान जिसके बारे में परिकल्पना की गई है और प्रतिदर्श के अनुमान दोनों एक समान है. Let us take an example. अगर हम किसी पॉपुलेशन से कुछ सैंपल्स लेके और सैंपल मीन अगर एस्टिमेट करते हैं तो सैंपल मीन इज अ रिप्रेजेंटेटिव ऑफ द पॉपुलेशन मीन, मतलब जो सैंपल है उसका मीन जो होगा वही पॉपुलेशन का मीन होगा. तो हम जो शून्य परिकल्पना लेते हैं वो मान के चलते हैं कि जो हमारा सैंपल है वही हमारा पॉपुलेशन है या सैंपल की जो यूनिट्स है वो भी दे आर एज सेम एज दी पॉपुलेशन या पॉपुलेशंस कंटेंस ऑल दोज सिमिलर यूनिट्स इज लाइक ए सैंपल. और शून्य परिकल्पना यही होती है कि देयर इज नो डिफरेंस बिटवीन द सैंपल मीन एंड पॉपुलेशन मीन, एंड इट्स ऑल्टरनेटिव हाइपोथेसिस इज there is a difference in sample mean and population mean. What is alternative hypothesis? Alternative hypothesis, any hypothesis complementary to null hypothesis is called alternative hypothesis. It is generally denoted by H1. The alternative hypothesis may be single-tailed or two-tailed hypothesis. For example, if H1 says that if first condition x bar is not equal to mu, means sample mean is not equal to population, that is two-tailed hypothesis. And the second is if x bar is not equal to mu, then second condition hold is x bar is less than mu or x bar is greater than mu, means sample mean is less than population mean, or third one is sample mean is greater than population mean. And these two hypotheses, x bar is less than mu or x bar is greater than mu, are called single tailed hypothesis. एकल पुच्छ हाइपोथेसिस इनको कहा जाएगा या एकल पुच्छ परिकल्पना, और एक्स बार इज नॉट इक्वल टू म्यू, इसे द्विपुच्छ परिकल्पना कहा जाता है. The table value of two tailed and one tailed test are observed as alpha% of single tailed and 2 alpha% for two tailed hypothesis. ऐसी कोई परिकल्पना जो शून्य परिकल्पना की पूरक हो वैकल्पिक परिकल्पना कहलाती है. वैकल्पिक परिकल्पना को H1 से प्रदर्शित करते हैं, और वैकल्पिक परिकल्पना जो है एकल पुच्छ अथवा द्विपुच्छ परिकल्पना हो सकती है. एकल पुच्छ मतलब सिंगल टेल, द्विपुच्छ यानी टू टेल. और एकल पुच्छ परिकल्पना कहते हैं वो है H1 such that x bar is not equal to mu, and द्विपुच्छ परिकल्पना x bar is either less than mu or x bar is greater than mu. Level of significance. What is the level of significance? The probability of happening of type 1 error is known as level of significance, or probability of rejecting the null hypothesis is known as level of significance. The level of significance usually implied in testing of hypotheses are 5% and 1%. 5% mean 95% our null hypothesis is true, but only there are 5% of rejection of this hypothesis, and this is called significant. And if there is a level of significance 1% means 99% null hypothesis is true and only there are 1% chances of rejection of null hypothesis. It is usually fixed in advance before collecting the sample information. सार्थकता का स्तर प्रथम प्रकार की त्रुटि होने की प्रायिकता को ही सार्थकता का स्तर कहते हैं. Probability of rejecting the null hypothesis is known at level of significance, या probability of happening of type 1 error is also known at level of significance. और सार्थकता का स्तर जो है वो हम 5% या 1% रखते हैं. What is degrees of freedom? स्वतंत्रता की कोटि. The number of degree of freedoms refer to the number of independent observations in the sample minus number of k of population parameters which must be estimated from the sample observations. स्वतंत्रता की कोटि किसी न्यादर्श में स्वतंत्र रूप से चुने गए प्रति चयनों की संख्या को स्वतंत्रता की कोटि कहते हैं. Errors of sampling. There are two types of errors in sampling. They are designated as type 1 error and type 2 error. What is type 1 error? Rejecting H0 when it is true is denoted by alpha. It is also known as producer's risk. Type 1 error, that is rejecting H0 when it is true and it is denoted by alpha, it is also known as producer's risk. What is type 2 error? Except H0 when it is wrong, it is denoted by beta and it is also known as consumer's risk. प्रति चयन में दो प्रकार की त्रुटियां हो सकती है. प्रथम प्रकार की त्रुटि जो है, यदि शून्य परिकल्पना को सत्य होने की स्थिति में भी हम अगर अस्वीकार कर दें तो इसे प्रथम प्रकार की त्रुटि कहते हैं. इसे अल्फा से प्रदर्शित करते हैं. एंड द्वितीय प्रकार की त्रुटि, यदि शून्य परिकल्पना को असत्य होने की स्थिति में अगर हम स्वीकार कर लें जबकि इसे स्वीकार करना था, तो इसे द्वितीय प्रकार की त्रुटि कहते हैं और इसे बीटा से प्रदर्शित करते हैं. अन्य शब्दों में, बाय परफॉर्मिंग अ टेस्ट वी मेक अ डिसीजन ऑन द हाइपोथेसिस बाय एक्सेप्टिंग और रिजेक्टिंग द नल हाइपोथेसिस H0. वी may reject H0 based on sample data when in fact it is true. This error in decision is known as type 1 error. And when we accept H0 based on the sample data when in fact it is not true, it is known as type 2 error. Here I am showing you table, and this is accept H0 and reject H0, and here H0 is true and H0 is false. If H0 is true, and if we accept H0, that is correct decision. And if H0 is true and if we reject H0, then there are chances of type 1 error. If H0 is false and we accept H0, then there may be a type 2 error. And if H0 is false and H0 is rejected, then that is the correct decision. So if H0 is true and we accept H0, that is the correct decision. If H0 is false and we reject H0, that is the correct decision. But these are the type 2 error is more vulnerable than the type 1 error. Test for a small sample. The large sample theory is based on two important assumptions that a random sampling distribution of a statistic is approximately normal. The values given by sample data are sufficiently close to the population values and can be used in their place for calculation of the standard error of the estimate. The above assumptions do not hold good in the theory of a small sample. Thus, a new technique is needed to deal with the theory of a small sample. A sample is small when it consists of less than 30 items. That is, n is less than 30, then we may treat it as a small sample. If n is greater than 30, equal to 30 or greater than 30, we treat it as a samples or large samples. Since in many of the problems it becomes necessary to take a small sample, it is necessary to develop a suitable tests for dealing with problems of a small samples. The greatest contribution to the theory of a small sample is due to Sir William Gosset and Professor R. Fisher. Sir William Gosset published his discovery in 1905 under the pen name student, and later on developed and extended by Professor R. Fisher. He gave a test popularly known as Ttest. Now it is known as student Ttest. What is student Ttest? If x1, x2, xn is a random sample of size n from a normal population with mean mu and variance sigma square, that is population mean mu and variance sigma square, then student's t statistic is defined as t is equal to x bar minus mu upon s upon root n, where x bar is the sample mean, mu is the population mean, and s square or s is the sample standard deviation, that is square root of 1 upon n minus 1 summation of x minus x bar square, or s square, that is sample variance, that is 1 upon n minus 1 summation x minus x bar square, and sample mean x bar is equal to summation of x by n, is an unbiased estimate of the population variance sigma square. And this s square is an unbiased estimate of the population variance sigma square, and it follows student t distribution with n minus 1 degree of freedom. Assumptions for students t-test. The parent population from which the sample drawn is normal. The sample observations are random and independent. The population standard deviation sigma is not known. Properties of a student t distribution are student t-test. T distribution ranges from minus infinity to plus infinity, just as does a normal distribution. Like the normal distribution, T distribution is also a symmetrical distribution. It has a mean 0. T distribution has greater dispersion than the standard normal distribution. If the sample size approaches to 30 or more, the T distribution approaches to the normal distribution. Application of T distribution. To test the sample mean x bar differ significant from the hypothetical value of population mean mu. प्रतिदर्श का माध्य की सार्थकता का परीक्षण. To test the significance of the difference between two sample means. To test the significance of an observed sample correlation coefficient. To test the significance of observed partial correlation coefficient. To test the significance of observed multiple correlation coefficient. To test the significance of sample regression coefficient, and to test the significance of difference of two regression coefficient. These are the uses of T distribution or T-test. Let us start with test of significance for mean by student Ttest. We set up a corresponding null and alternative hypothesis as follows: H0 such that the sample mean x bar equal to mean mu, that is population mean. There is no significant difference between the sample mean and population mean. And H1 such that mu or x bar is not equal to mu 0, means x bar is less than mu 0 or x bar is greater than mu 0. It is the two-tailed hypothesis and this is one-tailed hypothesis. Level of significance either are 5% or 1%, and calculation of statistics under the H0 is calculated value of t or t observed value is x bar minus mu upon s upon root n in modulus sign. If we got negative values, it becomes positive, or x bar minus mu upon s upon root n under root n minus 1, where summation x by n is the sample mean and s square is equal to 1 upon n minus 1 summation of x minus x bar chi square. If samples are sufficiently large, that is more than 25 or 26, then we calculate s square is equal to 1 upon n summation of x minus x bar square. The expected value or table value, the table value of t or expected value of t, that is x bar minus mu upon s upon root 10 student t distribution with n minus 1 degree of freedom, and we see the table value from the table given here. This is 0.05 means 5% level of significance, this is 0.01 means 1% level of significant table, and these are the degrees of freedom. We find out the corresponding table value from this table value and compare this table value with the calculated value of our t statistic. If the t calculated or t observed value is less or equal to t tabulated value, it falls in the acceptance region and the null hypothesis is accepted, and we say that there is no significant difference between the sample mean and the population mean. If, and second condition, if the calculated value of t this is greater than the table value of t, then the null hypothesis 0 may be rejected at the given level of significance, and we may say that there is a significant difference between the sample mean and the population mean. Thus, we draw inference from this test statistic t when we calculated value of t, compare with the calculated value of t with the table value of t at n minus 1 degree of freedom, and we draw inference like this. This is a t table for 0.05, this is highlighted, that is 5% level of significance, 0.01 that is 1% level of significance. Let us take an example. Certain pesticide is packed into bags by machine. A random sample of 10 bags is drawn and their contents are found to be weight in kgs as follows: 50, 49, 52, 44, 45, 48, 46, 45, 49 and 45. Test the average packing can be taken to be as 50 kg. The number of observations are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We set up first null hypothesis and H0 such that mu equal to 50 kgs in the average packing is 50 kg, and alternative hypothesis that the mu or sample mean x bar is not equal to 50 kg, that is two-tailed test, and level of significance is 0.05. Here we calculate the sample variance, and this is the values of x and x minus 48, that is d, and we a is a as mean and subtract 48 from each values. 50 minus 48 is 2, 49 minus 48 is 1, 52 minus 48 is 4, 44 minus 48 is minus 4, 45 minus 48 minus 3, 48 minus 48 is 0, 46 minus 48 is minus 2, 45 minus 48 minus 3, 49 minus 48 is 1, and 45 minus 48 is minus 3. And summation dx is minus 7, and summation d square of these deviation values, we have 2 square is 4, 1 square is 1, 4 square is 16, minus 4 is 16, minus 3 square is 9, 0 is 0, minus 2 square is 4, minus 3 square is 9, 1 is 1, and minus 3 square is 9, minus 7 square. And if we add all these values, we get summation d square is 69. And what is x bar? X bar is equal to a plus summation d by n, that is 48 plus minus 7 by 10, that is 48 minus 0.7, that is 47.3. This is the x bar. And what is s square? S square is equal to 1 upon n minus 1, summation d square minus summation d whole square divided by n. And summation d square is 69, and summation d is minus 7, that is square, becomes plus, and after solving these we get 7.12, that is the sample variance is 7.12, and after square root of 7.12 we get the value of standard sample standard deviation. Calculation of statistics under H0, and the test statistic T is equal to x bar minus mu upon under root of s square upon n, or s upon root n. S square root cancels with this square, this s upon root n. Otherwise we here is s square upon n whole root, and here we put the value. X bar is 47.3, mu is 50, s square is 7.12, divided by number of observations are 10, and after calculation we get 3.2, that is the calculated value of observed value. And the calculated value at 9 degree of freedom at 5% level of significance is 2.262. Here we see that this calculated value is greater than the tabulated value, and we say that the calculated value is greater than tabulated value, and H0 is rejected at 5% level of significance, and we conclude that the average packing cannot be taken to be as a 50 kgs. And this is the our final conclusion. Because the calculated value of test statistic T is greater than the tabulated value of T at n minus 1, that is 9 degree of freedom is 2.62. Therefore we reject H0 at 5% level of significance, and we conclude that the average packing cannot be taken as 50 kg. Let us take an example 2. A soap manufacturing company was distributing a particular brand of soap through a large number of retail shops. Before a heavy advertisement campaign, the mean sales per week per shop was 140 dozen. After a campaign, a sample of 26 soap was taken, and the mean sales was found to be 147 dozen with standard deviation 16. Can you consider the advertisement effective? Uh, Let us solve the example, and here we already given n equal to 26, x bar is 147 dozen, and s is equal to 16, and mean mu is equal to 140 dozen already given. Null hypothesis, we have taken mean mu 140 dozen, that is advertisement is non-effective against the sale of 147. And what is alternative hypothesis? H1 says that mu is greater than 140 kgs, that is right tilt. Alternative hypothesis we are taking here because the sales was more than the 140 dozen, that is 147 dozens after the advertisement. So such type of alternative hypothesis is right tilt hypothesis. If mu is less than 140, then that would be a left tilt alternative hypothesis. Here we are taking right hypothesis H1, calculating the test statistic, that is under the null hypothesis H0 T observed is equal to x bar minus mu upon s upon root n, and x bar is 147 while mu is 140 and s is 16, and there were 26 observations, that is root 25, and that is 147 minus 140 is 7, and root 25 become 5, and this is 16. 35 divided by 16, that is 2.19. What is the tabulated value of T at 26 minus 1, that is 25 degree of freedom, that is 1.708. Thus the calculated value is greater than the tabulated value. Means since t calculated value is greater than the table value and h0 is rejected at 5% level of significance, and hence we conclude that the advertisement is certainly effective in increasing the sales, because before advertisement sales was 140 dozen, and after advertisement the sales rise up to 147 dozen, so that we conclude that the advertisement is certainly effective in increasing the sales. Let us start with test of significance for difference between two means. Earlier, the students Ttest we have tested for single mean, but in that case we are taking the test of significance for difference between the two means. Means there are two samples. First question, if the samples are independent, what are the assumptions? The parent population from which the samples have been drawn are normally distributed. The two samples are random and independent of each other. Conditions for applying this student t-test or two-mean t-test. The population variance are equal and unknown. Sizes of the samples are small and may be different or same. Thus, before applying t-test for testing the equality of means, it is theoretically desirable to test the equality of the population variances by applying f-test. If the variances do not come out equal, then t-test become valid. Two mean t-test. Test of significance for difference between two means, and the samples are independent samples. Suppose we want to test if two independent samples have been drawn from two normal populations having the same means, the population variances being equal, that is, let x1, x2 up to xn1 and y1, y2 up to yn2 be two independent random samples from the given normal population. The null hypothesis h0 such that mu1 is equal to mu2, that is, the samples have been drawn from the normal populations with same means, and alternative hypothesis mu1 is not equal to mu2, that is two-tailed alternative hypothesis, and if one-tailed mu is less than mu2 or mu1 is greater than mu2. The test is statistic t, that is x bar minus y bar. X bar is the mean of the samples of x sample, and this is y bar is the mean of the y sample, and s into root of 1 upon n1 plus 1 upon n2, where x bar is equal to summation x upon n1 and y bar is the summation y upon n2, and s square is the pooled variance of both the samples, that is 1 upon n1 plus n2 minus 2, summation of x minus x bar square into summation of y minus y bar square. After simplifying, we may also write n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2, where s1 square is equal to summation of x minus x bar square and n2 s2 square is equal to summation of y minus y bar square. Putting the value of summation x minus x bar square is equal to n1 s1 square and summation of y minus y bar square is equal to n2 s2 square, and this is n1 plus n2 minus 2. And this follows t distribution with or t test with n1 plus n2 minus 2 degree of freedom. The expected value of t or tabulated value of t that follows the t distribution with n1 plus n2 minus 2 degree of freedom. And inference we may draw from calculation, if the t calculated value is less than t table value, we accept the null hypothesis. If t calculated value is greater than t tabulated value, we reject the null hypothesis. Example: a group of 5 persons treated with medicine A with 42, 39, 48, 61 and 41 kg, and second group of 7 patients from same hospital treated with medicine B and weight is 48, 38, 42, 56, 64, 68 and 69 and 62 kg. Do you agree with the claim that the medicine B increases the weight significantly. And start the solution. Let the weight in kg of the patients treated with the medicine A and B be denoted by the variable x and y respectively. And the null hypothesis H0 such that mu1 is equal to mu2 method. There is no significant difference between the medicine A and medicine B as regards their effects on increase of weights. Alternative hypothesis H1 says that mu1 is less than mu2, that is left tail, that is medicine B increases the weight significantly. That is mu1 is the average weight of medicine A and mu2 is the average weight of medicine B. Then we said this is the left tailed hypothesis, and medicine B increases the weight significantly. Level of significance alpha is 0.05, and computation of sample mean as standard deviation as follows. This is the values 42, 39, 48, 60, 41, and that is summation x is 230. And this is x bar is summation x by n1, that is number of samples are 5, that is 230 divided by 5, that is 46 is the x bar, and this is the x minus x bar. After subtracting the x bar from these x values, 42 minus 46 is minus 4, 39 minus 46 is 47, 48 minus 46 is 2, 60 minus 46 is 14, 41 minus 46 is minus 5. Squaring up this observation, we will get a summation of this x minus x bar square. Minus 4 is 16, minus 7 square is 49, 2 square is 4, 14 square is 196, and minus 5 square is 25. And after summing all these values, that is summation of x minus x bar square is 290. And this is the summation of x minus x bar, that is always 0. This is the properties of mean. This is the medicine B, y 38, 42, 56, 64, 68, 69, 62. Summation y is 399, and y bar is equal to summation y upon n2, that is 399 divided by 7, that is the mean weight is 57, and s square we calculated by this formula. Before calculating these, we first calculate y minus y bar. 38 minus 57 is minus 90, 42 minus 57 is minus 15, 56 minus 57 is minus 1, 64 minus 57 is 7, 68 minus 57 is 11, 69 minus 57 is 12, and 62 minus 57 is 5. And here y minus y bar is this, and summation of y minus y bar is 0, that is the properties of mean, arithmetic mean, and this we calculate y minus y bar square. Squaring of these observations, minus 19 square is 361, minus 15 square is 225, minus 1 square is 1, 7 square is 49, 11 square is 121, 12 square is 144, and 5 square is 25. That is the summation y minus y bar square. Putting the value of the summation x minus x bar square and y minus y bar in this pooled sample variance, that is 1 upon n1 plus n2 minus 2, summation of x minus x bar square plus summation y minus y bar square, and summation x minus x bar square is 290, summation y minus y bar square is 926, and this is n1 plus n2 minus 2, 5 plus 7, 12 minus 2, that is 10, and this is s square is 121.6. Putting the values of x bar, y bar, and s square and n1, n2 in the formula, and we get x bar, y bar under s square 1 upon n1 to 1 upon n2, that is x bar minus y bar is difference is 11, that is 46 minus 57 divided by s square is 121.6, and 1 upon n1 is 1 upon 5 plus 1 upon 7. After solving these, we get 11 upon root of 1 to 1.6 into 12 upon 35, and after solving this square root sign, we get 11 upon 16, 6.57, that is 1.7. This is the calculated or observed value of test statistic T in case of 2 mean T test, and the expected value or table value of T at n1 plus n2 minus 2, that is 5 plus 7, 12 minus 2, that is 10 degree of freedom, is 1.81. Here we see that this is the calculated value and this is the table value. The calculated value is less than table value, and here we see that we accept H0, there is no significant difference. Hence H0 we have accepted, and we conclude that the medicine A and B do not differ significantly as regards their effect on increase of weight. Means medicine B is not significantly differ from A. Both the medicines are similar, or we may say that both the medicines are similar because we accept the null hypothesis. Under the null hypothesis, we suppose that both the medicines have do not differ. Thus, we draw the inference from these calculated and table values of T. And this is the pair Ttest, test of significance for difference between two means, and that is related samples. In that case, the samples should be related. Both the samples are if independent, then we use only two mean Ttest to test the significance of difference between the two means. Here, both the samples are related, so we use this pair Ttest. In the Ttest, the difference of means the two samples were independent for each other. Let us now take a particular situation where the sample size equal to n1 plus n2, that is n, and the sample observations are x1, x2 up to xn and y1, y2 up to yn are not completely independent, but they are dependent in pairs. We also taking two observations, one before treatment and other after the treatment on the same individual, that is both the observations are correlated. Means in that situation we take two observations simultaneously on the same unit, one before the treatment and another after the treatment, so that both the observations are related, or both the samples we have collected from the same unit, so that we may say that these samples are related. To calculate the expected value of E, that is d bar upon s upon root n, we follow T distribution with n minus 1 degree of freedom. Let us start with test of significance for difference between two means, that is the related samples, and it is known as pair T-test. In pair T-test, the difference of means of two samples are related, and now we have the situations where the sample sizes are equal, that is n1 barabar n2 equal to n, and the sample observations are x1 x2 up to n1 and y1 y2 up to n are not completely independent, but they are dependent pairs. Here we are taking two observations, one before the treatment and another after the treatment on the same individual, that is both the observations are correlated. Means we are taking two observations, one before the treatment, one and other after the treatment on the same units, and so that we said both these observations are related. In pair T-test, let di is equal to xi minus yi, where xi is x1 x2 up to n and yi are y1 y2 up to yn, denote the difference of the observations, and null hypothesis is 0 such that mu1 is equal to mu2, that is the increments are just due to chance, or there is no significant difference between means of both these samples. And alternative hypothesis, there is a significant difference between the mu1 is not equal to mu2, either mu1 is greater than mu2 or mu1 is less than mu2. This is the two-tailed alternative hypothesis, this is the one-tailed alternative hypothesis. To calculate the test statistic T, that is calculated value of T or observed value of T, that is d bar upon s upon root n. What is d bar? D bar is the mean of the difference of n pair of observations, that is y1 x1 y1 x2 y2 x3 y3 up to xn yn, and the difference are d1 d2 up to dn, that is summation d by n is the mean of differences, and that is the d bar. And what is s square? S square is 1 upon n minus 1, that is summation of d minus d bar square. After subtracting the mean of d bar from each of di and taking the squares and then taking sum, and that is divided by n minus 1, we will get the s square, that is standard deviation. That is equal to 1 upon n minus 1 summation of d square minus summation d square ka whole square divided by n. After solving or after simplifying this s square, we get this formula. Thereafter, we compare the calculated value with table value of, and the table value and t expected, that is d bar upon s upon root n, follows the t distribution with n minus 1 degree of freedom, and we make the inference from the calculated value of t and table value of t by comparing t calculated and t tabulated desired level of significance at 5% and 1% level significance. If t calculated is less or equal to t tabulated, then we accept the null hypothesis, and if t calculated value is greater than t table value, then we accept the alternative hypothesis and reject the null hypothesis. Let us take an example. Following are the observations on organic carbon percent obtained from soil core samples drawn from two different layers of a number of soil pits in a natural forest. Compare the organic carbon status of soil at two different soil depth levels. प्राकृतिक वन में मिट्टी के गड्ढों में दो विभिन्न गहराइयों पर उपलब्ध ऑर्गेनिक कार्बन परसेंट नीचे दिए गए हैं। मिट्टी की विभिन्न गहराइयों में ऑर्गेनिक कार्बन की उपलब्धता की तुलना कीजिए। And these are the soil pits 1, 2, 3, 4, 5, 6 up to 10. And this is the layer 1 organic carbon percent 1.59, 1.39, 1.64, 1.17, 1.27, 1.58, 1.64, 1.53, 1.1, 1.48. And at layer 2 1.21, 0.92, 1.31, 1.52, 1.62, 0.91, 1.23, 1.21, 1.58 and 1.18. H0 says that x bar equal to y bar or mu1 equal to mu2, and H1 says that x bar is not equal to y bar and level of significance is 5%. And this is the table, these are the pits number, and this is the layer 1, this is the layer 2, and D is the difference between x and y, that is 1.59 minus 1.21, that is 0.8, 1.39 minus 0.92, that is 0.47, and 1.64 minus 1.7, that is 0.33. This is the difference of minus 0.35, and difference is minus 0.35, 0.67, 0.41, 0.32, minus 37, and 0.30. That is sum of the differences. Summation D is 1.81. What is D square? Square of each observations, and this is the summation D square, that is 1.6655. D bar is 1 by n summation of di, that is summation di is 1.81 divided by 10, that is 0.81, and s square is 1 upon n minus 1 summation of di minus d bar square, and that is 1 upon n minus 1 summation di square minus summation di whole square divided by n. Putting the value 1 upon n is 10 minus 1, that is 9. Summation d square is 1.6655 minus 1.81 whole square, that is summation d square divided by number of observation 10. After solving this, we get the 0.1486. And test statistics T is equal to d bar upon s upon root n. Putting the value of d bar is, that is 0.181 from here, and this is the s upon root n, that is the value of s square, that is 1.1486, that is 0.1486 divided by 10, that is the square root of these whole values, and it comes about 1.485. Observed table value T is 2.262 at 10 minus 1, that is 9 degree of freedom, that is the table value, and at 5% level of significance. If we compare the calculated value of T with the table value of T, we see that the calculated value of T 1.485 is less than 2.262. It may therefore we conclude that there is no significant difference between the mean organic carbon content in both the layers. It means we accept the null hypothesis, that is x bar equal to y bar. Let us take an example. An IQ test was administered at 5% before and after they were trained. The results are given by candidate 1, 2, 3, 4, 5. IQ before training, candidate 1 got 110, second got 120 marks, third got 123 marks, fourth got 132 marks, and fifth got 125 marks. After IQ, after training was given, and after training, IQ was tested, and first candidate got 120 marks, second got 118 marks, third got 125 marks, fourth got 136, and fifth got 121. Test whether there is any change in IQ after training program and test at 1% level of significance. Solution: first we establish the null hypothesis, that is H0 such that mu1 equal to mu2, that is there is no significant changes in IQ after the training program, and alternative hypothesis such that mu1 is not equal to mu2 to test hypothesis, and level of significance are is alpha level 0, 1 or 1%, and x is given 110, 120, 123, 132, 125, and y is given 120, 118, 125, 136, 121. D is equal to x minus y. This is the difference: minus 10, 2, minus 2, minus 4, 4, and minus 10. And d square is 10 square is 100, 2 square is 4, minus 2 is 4, minus 4 is 16, and 4 is 16. Summation d is minus 10 and summation d square is 140. Putting the value of summation d by n, that is minus 10 divided by 5, that is d bar is minus 2, and s square is equal to 1 upon n minus 1, summation d square minus summation d whole square upon n, that is 1 by 4. Summation d square is 140 and summation d square is minus 10 square is 100 divided by 5, that is 140 minus 20, that is 120, and 120 divided by 4, that is only 30. S square is 30. Putting the value in the formula, d bar upon s upon root n, and here d bar is minus 2 and s is 30 and n is 5, that is square root of 30 upon 5, and that is 2 upon 2.45, that is calculated value at is 0.816. What is the table value? Table value d bar upon s square upon root, that is follows t distribution with 5 minus 1 4 degree of freedom, and degree of freedom table value is 4.604, that is 1% level of significance, and we conclude that the calculated value of t is less than the table value t, the 1% level of significance, and we accept the null hypothesis, and we therefore conclude that there is no change in IQ levels of the participants after the training program. Thanks, dear.